Thank you so much for being here for my session. Before I start, I just would like to ask some of you guys here, some of you guys using EKS? Nice. Have you heard about Carpenter? Okay, nice. Just imagine that if you would like to host a party and you don't know really that how many people will join your party, right? So you need to provide a fixed number of table, and then two things will happen. Or maybe one case is that it's overcrowded. Too many people, we cannot find a table anymore. And another one is that just half the number of people that we expect to come, just come. We don't be over-provisioned. That is how Kubernetes do it right now, because it's spin up a upfront capacity for your pods to be scheduled on it. And that's why I would like to introduce you to the Carpenter. So, hi, my name is Chakkree, a solution architect from AWS. I am in a container technical field community, just like a specialist or something like that. So let's dive in about Carpenter. Just think about the table that I mentioned. Imagine that we have something like this, the table that can shrink or can expand it whenever needed. So this is how Carpenter working actually is try to fit your workload in the right size of the compute. So let's see what kind of challenge that we are facing today with the EKS or with the Kubernetes in another cloud provider. So here we have the instance running 2 pods already, and we have our deployment. We have some pending pods there. Let's say that the instance here have 2 CPU, is M5 large, and the pods consume 0.5 CPU. So EKS, when it needs additional capacity, it will work with cluster autoscaler, you may know, and also it will work with autoscaling group, 2-step, and autoscaling group will work with EC2 API, 3-step actually. So here, cluster autoscaler can scale the pods, can scale the number of nodes and schedule a pod successfully. And you can notice 2 things here. There are 3 steps to do it. So it will take some time, like 3 minutes or 4 minutes, depending on the image of your AMI or your instance. And the second problem here, you can see that on the right instance here is underutilized because you use only 0.5 vCPU from the instance side of 2 vCPU. So 2 problems here. And another one is that if you have different kind of workload, you have the notebook for the compute, CPU intensive, but another one needs GPU, maybe GenAI inference or something like that. Cluster autoscaler cannot schedule a new instance for this pod because it needs a new node group and also a new cluster autoscaling group. So for the admin, with new workload, they need to spin up a new node group. So this one is the existing one. And the new one is the GPU node group. So then after that, it can be scheduled. So this task will be gone if we use Carpenter because it will find the right size and also the right type of GPU or CPU for your pods to run. So we have 3 challenges here. The time to spin up a instance, also the right sizing, and also the underutilized node. So how Carpenter works? So here is the cluster autoscaler that we have pending pods. It works with cluster autoscaler. It's work with autoscaling group and then call the API of EC2. But for Carpenter, we will get rid of the concept of the node group. We will not need the node group anymore. We don't need the autoscaling group. It just works with the EC2 API directly. Cut a lot of time and process. And here, how it works for the GPU workload. We have now C5 to X large, which doesn't have the GPU at all. When the GPU comes, it will just spin up a new GPU workload for you. This one is another type of instance that can use to schedule the pods for you. Problem 1 solved. And this is actually the key configuration that you can do with the node pool. There are a lot of things that you can do with the node pool, a lot of parameters, but these are the key. So you can see that it's already launched as version 1. We graduated from the beta like last 3 weeks, and now it's already in version 1. So here you can choose the instance type. You can choose C5 or M5 or R5 or something else in another cloud provider, but you can choose different type that you would like to run your workload on. And then you can choose the availability zone. Also, you can choose the architecture of your CPU. If you would like to save some more cost, you can use ARM CPU, which provide better price performance. And also, you can use Spot to save some cost if your application can tolerate with the disruption, or you can use on demand. And another piece that I would like to show in the demo as well is the limit. You can limit that this node pool can provision only 100 CPU. And after that, it will not provision any more instance to save some cost or to control the budget. So these are just some key elements that I would like to walk you through. So for node pool, you can have one node pool or multiple node pool. So if you would like to use like one node pool, you can just use this one for scale the number of instance across the cluster. But sometimes it will be like multiple node pool because you may need like a separated team to control different instance type, or like one node pool for CPU workload and one node pool for GPU workload. And you can also use weighted node pool as well. By default, it will use the node pool number one. And when it uses up until the limit, 10 CPU or 100 CPU, it will use the lower weighted node pool. So you can have three different strategies here. And let's see about the cost optimization when the instance here is underutilized. You can see that we have two underutilized nodes on the right-hand side. And in the configuration, we can specify that we would like to do the consolidation when the node is empty or the node is underutilized. And the consolidation after here is the time that if we do the consolidation. So here is just like 0 seconds. So it will disrupt everything that is running on these two pods. So we can say, let's say 1 hour or 24 hours, we can do something like that as well. So here, Carpenter, we find that these two instances are underutilized, and we try to group together or move the pod for you to this instance. And another case, you may have something like this. So a bigger instance, but we have only one pod running. It will try to group together these two pods to find the right size of the new instance. It will spin up a new instance and drain the pod for you automatically. So these are two features if you would like to enable the consolidation to save some cost. But just keep in mind that your workload needs to be tolerated with the disruption. You can decide with the time. Here, another feature that just launched when we graduated to version 1, you can also do the automatic upgrade by using another configuration. It's called EC2 node class. You can specify that your workload would like to use this version of image, or you would like to use the latest one. If you would like to use the latest one, it will just update automatically. You don't need to do anything. You can also pin the version here. I would like to use version 1 only. When the new AMI come out, it will not update for you. Or you can use your custom AMI as well. Yeah. And I think we can go to the demo. It's quite a long one, but I would like to show you that, how it works. I would love to show this one live, but the time is limited. Okay, we have two nodes here. We have 3 large, 2 nodes for control plane. Let's see my deployments, so what kind of things that I have. So this one is EKS. I have, this one is called DNS, just for the DNS that auto scale. And also this one is for controller of Carpenter, that is in Carpenter namespace. And this one is my workload. It's just like a simple workload that requests for maybe one CPU, just check. We'll go into the workload and check. I think it's like a simple workload that pull the image from public ECR repo. The name here is inflate, namespace is inflate. So let's see. Yeah, here CPU is one CPU only. I didn't specify the memory. And the repo is just like public repo. It's do nothing. It's just allocate a CPU. And let's see that what kind of node pool configuration that I have. So the configuration that will specify how Carpenter will behave in my cluster. I have only one node pool here. You can have multiple, just like I mentioned. So here, the name is default. You can change the name as well. and the version is already 1. So back then it's like beta or something. I will do consolidation when it's empty, when the node is empty, within 5 seconds. And also I do the limit here is like 10. We will test on this one. And for architecture, for now, I will use just x86 only. And the capacity type, I will use on demand. But we will add some more later. So here, and also here, you can control the instant category as well. I would like to use C type, M type, and R type. Yeah. You can use this wildcard as well. Okay, you can specify availability zone and something else as well. So let's scale my workload into maybe 5. So 5, it will goes up. Here you can see that we have 5 pending pods and 8 running. And yeah, here it's super fast. It just come up with a new node to fit all that 5 pending pods. It's not ready yet because it takes some time to boot. And here it just tell you the price of the overall cluster. So now there are 2 pods here because it's like kubelet and also kubeproxy for the node to come up. And then if you try to schedule those 5 pending pods. Yeah, just like within 1 minute, and then your workload is already scheduled. And with the right size of the instance. I would like to show some logs here, but it's like quite technical. Here, I would say you try to come up with a node that fit the 5 pods that we request. And then it will figure out what kind of node that will maybe best fit for this. So it will look into the instance type that we specify, C type, M type, R type. You can see here 43 others instance type that we will look into. And it will choose the cheapest one for you. So this one, it come up with a C6H can fit 58 port and have 7 or 8 CPU, something like that. Yeah, so now it's already registered and ready to schedule your pods. So here, how it works behind the scene for Carpenter to come up with the right size of the pods. And then I would like to scale out more. Maybe the scaling is from K8s or from HPA, depending on your cluster. So I scale to 20. Can you guess what will happen? Because we put the limit, right? So I'm not sure. So here is to spin up one instance. Maybe it can schedule 1 pod or 2 pods. Let's see. And then it will hit the limit. So here is coming up 2 pods, and then maybe just 1 pod can be scheduled because it's support like maybe 1 or 2 CPU. Yeah, just 1 pod there, and then we still have 12 pending pod because Carpenter node pool cannot spin up more instant because it reached the limit already. If you can remember that I put just 10 CPU for the node pool to be able to spin up a new node. So here is the log. So it say that all available instance type exceed the limit for the node pool name default because I put it at 10. So let's increase that. I increase to 1000, I think. And then it will try to spin up a new node that fit 12 pods. So here I change to 1000. And then let's check again so that we can remember where it is. So here up there, we change from 10 to 1000. So this node pool now can provision, it's just come up for 12 pending pods, 6 CPU. 12 CPU, sorry, because it's used 1 CPU. So here the same process kicks in, choosing the cheapest one and then, spinning up, scheduling. I would like to add the ARM as well, the graviton from our side that provide better price performance. And also, I also would like to add the spot to save some cost as well. So here I add spot and ARM. So let's check again in the configuration. Yep, it ran 1 pod to another one here to save some cost for you. Yeah. So here we have ARM 64 already, and we try to use ARM. You need to guarantee that your application support ARM by doing POC and something like that. And also spot as well. We can put two value here, spot or on demand, but it will try to prioritize spot. Yeah. So maybe we will see spot coming up sometime if it is available. Let's see. But I will move to another one, I think, which is, what is that? Let's see. Yeah, so here we have spot. And you can specify the G here. The G is from graviton. Graviton is the ARM. So cheaper than x86, but you need to make sure that your application support it. Yep. That is pretty much it, but I would like to show more like 10 and toleration and other things that Carpenter also support. Pod disruption budget, it also support. Pod affinity, yeah, everything that you do. AC spread as well. I think AC spread, we will test next. Let's see. Also consolidation, because now the consolidation is when it's empty, right? But I would like to change to when empty or underutilized as well. So here I will try to reduce the number of pods, and I will try to consolidate the cluster for you. Already changed to when empty or underutilized here. So this node here is underutilized. I will try to reduce the number of pods. Yeah, reduce to 10 replica maybe. Yeah, there is this one maybe underutilized because it's used only 20% of CPU. So let's see what kind of things that. Yeah, so here you try to rebalance everything to use the right size and reduce the pay for you here. This way it just speed up because it takes some time to come up with a new instance. Yeah, here we have this one underutilized. Maybe we try to consolidate again. Yep. Deleting this one, coming up with a new one, and then drain it for you. Do the cordon and everything. Okay. I think I will show the last one. I think it's like AC spread. The 10 and toleration. So you can specify in the node pool that you would like to do the 10 for the node that's spinning up by Carpenter. If the deployment doesn't have the 10, it cannot be scheduled in those nodes. So 10 and toleration will work. So here I put the 10 as key as my name, Chakkree. And then I will try to spin up a new pod. Yeah, 15, but I think unfortunately that it can fit into this one, so it still can be scheduled. That's why I increase more to have a pending one. So there are 5 pending pods that doesn't have the toleration for 10 key as Chakkree. So now Carpenter cannot spin up a new instance for you. So here we can see that the deployment cannot have a 10, cannot have a toleration for 10 Chakkree. I will try to add that toleration to my deployment. Let's see. Here I already add the toleration for my deployment, and hopefully it will comes up with the 10 pending pods. Here, immediately it will come up with a new node for you. So you can see this one is some kind of demo that would like to showcase some of the feature, but there are a lot of features out there that you can explore for Carpenter. And there is a workshop available as well. So here I would like to conclude that it's super fast because it just cut out some of the process to work with auto scaling and also cluster auto scaler by working with EC2 API directly. Also, it will help you to save some cost for your cluster because it tries to do the consolidation. And is Kubernetes native. Now it's support to cloud provider. I'm not sure about the third cloud, so maybe coming next. So now it support AWS and also Azure. And yeah, it's super awesome. I think I really love Carpenter and would like it to be graduated from the beta, but yeah, it's already there. Thank you so much for your attention. Yeah. Any question?
Just very quickly, does it run as a daemon set or is it as a...
No, it's just like deployment.
Okay.
Yeah. And for those deployment, you don't need to run it on the node that managed by Carpenter. Maybe you need to run on Fargate or you need to run on a separate node group.
Okay, thank you. And one more quick question. What type of metrics are exposed that we could use for Prometheus? So I noticed you had like cost, for example. Presumably you're getting it direct from the EC2 API, but is that exposed as well after the fact so we can use it in Prometheus queries?
Yeah, you can do it because we just announced that we support Carpenter observability with multiple metrics that can be exported to Prometheus. Yeah. I had a slide, but I cut it out. Yep. Sure.
Just a quick question. Do you guys work closely with the folks from GitHub? Because I think like these two things might have worked pretty well together.
Yeah, sure. So this one is actually in GitHub. We actually lead this initiative and then contribute a lot, but we would like to keep it open source. That's why we put it in GitHub. So a lot of contributors are coming from AWS side. Yeah. And you can also see the updates and everything about the pipeline or roadmap there as well. And there is a best practices in GitHub as well about like how to do the configuration for node pool and also EC2 node class. Yeah.
Thank you. First of all, a quick one. is it configurable with the definition of underutilized? Or is it something you can control what is exactly underutilized?
For now, no.
Okay.
Yeah, for now, we have our own like judgment, like maybe under 50%.
Excellent.
Yeah.
The other one, please. So if, because of a sequence of events, it ended up that, okay, we have 2 machines utilized on demand, and then I added that spot machines can be one option. And then no events happens. Will it automatically fire up new spot beans and migrate?
Yeah. So you have 2 cases here. So you can have a ratio between spot and the on-demand. You can configure that, but I didn't show it.
Okay.
But if you put these 2 values, spot and on-demand, it will try to prioritize spot.
It will. Okay,
Yeah.
thank you.
Yeah.
Thank you so much.
Nice. Nice question.
Yes, thank you for your presentation. We're also running Carpenter in production. We really love it. I can confirm all the pros that you had on your slide.
Any cons?
There is a con that we are struggling with, and I don't know if it's something in our configuration or it's something within Carpenter, but what we see happen from time to time is that Carpenter is spinning up nodes just in one availability zone, and which is leading to IP exhaustion in our subnets. And is that something that can be tweaked using the configuration, or is it a known issue to you guys?
Are you using AC spread in your deployment?
Not really, because the workloads don't really allow it.
Okay. So that is one way to do it. And when we launch version 1, are you using version 1 now?
Yeah, we are up to date.
I think already they try to balance the node spinning up. But let's have the discussion further for that one. So maybe it's the known issue, but I will let you confirm that.
Yeah, I will look you up later.
Yeah, sure.
Thank you.
Thank you. Any more questions? Thank you so much for having me. And yeah, just add me on LinkedIn and everything. You can just reach out to me anytime. Thank you.